we did define the word wave in physics terms. And the result of our discussion was we got this definition: a wave is a traveling disturbance. And in this definition, the most important thing is that you should know what this word means in the definition. So, what is it? It's actually the imparted energy and not the particle. Okay, it's a traveling imparted energy and not a particle. So basically, wave is a traveling energy, but in the process, it doesn't transfer the particle. It remains there in the relatively same position. Okay. Another thing that you should be aware of in this definition is the word traveling. It's very important to imagine wave as an entity that is actually traveling, so it must have a speed. Okay. Every wave has their own speed. Right? There's a movement of this thing, and actually, this movement is the basis of the classification schemes that we discussed last session. Okay, and we have two classification schemes. We have four terms that usually come out whenever we ask for the type of wave or the kind of wave. Okay, those are called classification schemes. We have two classification schemes. The first classification scheme is based on the presence or absence of a medium. Okay, whether a medium is required or a wave can travel with or without a medium, then the classification scheme is based on this. And in this kind of classification, we have two different types of wave. The first one is mechanical, and the other one is electromagnetic. So mechanical is basically that type of wave that requires a medium to propagate. Okay, without a medium, that that kind of wave won't exist. Now, the other one is the electromagnetic wave. Electromagnetic wave is kind of like a family of many different kinds of wave. It's starting from microwave, then going to the infrared, then light is also an example of it. Then infrared, we have ultraviolet also. We have X-rays and gamma rays. This belong to this family of wave. Sometimes they call it electromagnetic spectrum. And these family of waves, all right, each member of these can travel with or without a medium. Classification scheme number one is either mechanical or electromagnetic wave. And the basis for this classification is the presence or absence of a medium. Now the next classification scheme that we have, I told you we have two. The other one is on the directions of the wave itself and the oscillation of the particles. If you disturb something, then that disturbance or the energy will be passed from one molecule to another. Now the direction of passing energy, all right, the general direction is the direction of the wave. And then when this happens, the particle will also vibrate or oscillate. Okay, and that's another direction. Now, if you're going to look at those directions, and you found that directions are parallel with each other or anti-parallel with each other, then that's one type of wave. I'm sorry for that. I'm sorry. I'm recording outside of my house. Now, as I said, if the direction of the wave motion, or where the energy is going, and the direction of the oscillation of the particle is parallel or anti-parallel, then you call it longitudinal wave. The other type of wave in this classification scheme is the wave that is called transverse. Okay, when longitudinal is parallel, this transverse is perpendicular. Now, in this case, the direction of motion is, say, going rightward, and then the oscillation of the particle is up and down. All right, up and down, meaning at the y-axis, and the direction of the wave or the energy, where the energy is going, is rightward, or the x-axis. You see, you will be having 90 degrees there, and that's perpendicular. Okay. Right? Two classification schemes. One classification will give you mechanical and electromagnetic, and the other classification scheme will give you longitudinal and transverse. Waves can be a mechanical and a longitudinal, or it can be mechanical and a transverse, or an electromagnetic and a transverse, things like that. But a wave that is a mechanical and an electromagnetic is not possible, right? This portion is going to be something related to the examples of these waves, or whether you can classify them into using the two different schemes. An example here, the sound is a wave, and another one, a wave produced on the rope, and water wave, and light. For the sound wave, what how do we classify sound wave? This sound wave is either mechanical and longitudinal. Okay, mechanical in the sense that it the energy is being passed from one air molecule to the next air molecule to the next until it reaches your ear. Okay, so it requires a medium. If there is no air between you and a speaker, then you cannot hear the sound. Right? Sound will not exist without a medium. So sound is a mechanical wave, right? And then if you're going to look at the direction of the wave velocity, or the direction of to which the energy is being transferred from one molecule to another, and you're going to look at the direction of the oscillation of the air particles in this case, and you will see that the orientation is parallel and anti-parallel. Okay, so that makes it longitudinal. Okay, in the same manner, rope is a mechanical wave. There's a rope wave because there's a rope. Okay, and if you vibrate one end of a rope, then the particles in the rope will be oscillating, just say up and down, and then the energy being transferred from one molecule to the next molecule, generally speaking, it's going to the right like that. Okay, that makes 90 degrees orientation or perpendicular. All right, that makes it a transverse. Okay, now in the case of the water wave, this is kind of tricky because the oscillation of the particle at the surface may be different from the oscillation of the particle at the bottom part of the water. But my example here, we are just going to concentrate on the surface of the water. Now, the surface of the water, when you disturb the water, you imagine you have a water, you left it overnight, so it's going to be calm, all right, undisturbed water. When you dip your finger in there, you are actually disturbing it. You are actually imparting an energy on it. And that imparted energy will cause the water to vibrate and produce wave, all right? What kind of wave? A water wave, of course, okay? Water wave exists only when there's water, all right? So this must be a mechanical wave, okay? And at the same time, the surface of the water will be like the one that you're seeing whenever you go to beaches, right? You will be seeing like particles of water. You cannot see particles, but generally speaking, the water is moving up and down, right? And then it is also at the same time moving in a horizontal direction. That makes the direction of these two motions that I was telling you about a while ago perpendicular. So that's transverse wave. Now, in the case of light, light is an electromagnetic and at the same time transverse. By the way, the lecture that light is actually chapter 12. Now, what we are dealing right now is chapter 13. The reason why I want to start with chapter 13 is because light is just under this um, broader broader topic in physics. All right, see, wave. We have to know what the concept of wave first, and then as you go through the examples, light is just one of those examples. Okay, so I thought and I planned to deliver my lectures with chapter 13 first, and then followed by chapter 14, which is sounds, and then go back to chapter 12, which is light. Okay, and then we end the term with chapter 15. Okay,